Hello everyone, welcome back to our video on Pythagorean Theorem. I'm going to continue with some medium examples. We saw some very simple examples in the first video. Now we're going to do some videos that are typically part A questions or part B questions on exams. Okay, so multiple choice type questions or part B, short answer questions. Okay, so this question here says to find the area and the perimeter of the following shape. So we have, in this example, a right angle triangle. Since it's 90 degrees, we can use Pythagorean theorem. We have the 50, which is your hypotenuse, the longest side. This is what we call C. We have the left side, let's call that A, and we're looking for B. So let's start off by finding the perimeter. In order to find the perimeter, you have to add up all the sides. We're missing B. We have to find B. So let's apply Pythagorean theorem and solve for the missing side. So we get 50 squared equals A is 14 squared, and we're looking for B, the base. So 50 squared is 2,500, 14 squared is 196, plus B squared. Remember, we're trying to isolate for B squared, so what do we have to do? We have to put our numbers on the same side and our variables on the opposite side. That means we have to bring the 196 over on this side because we're trying to isolate the B. How do we do that? It's being added, so we subtract, inverse operations. We subtract by 196 on both sides. Okay. So what we're left with is B squared equals 2,500. Let's calculate that. 2,500 minus 196. And we get 2,304. Last step of Pythagorean theorem, you have to always square root. We're not looking for B squared, we want just B. So we square root both sides. Square root of B squared is B. Square root of 2,304, we get 48. The units are in meters, so that's the base. So B equals 48 meters. Does that make sense? Yes, it does, because our hypotenuse is the longest side is 50. This side is smaller. Good. Let's keep going. How do we find the perimeter? Out of all sides. So perimeter equals, I'm going to put a little triangle. So the perimeter of the triangle is equal to 14 plus 50 plus 48. We use our calculator. And we get the perimeter is 112 meters. That's the answer for the perimeter. Next, we want to find the area. How do we find the area of a triangle? Well, the area of the triangle, the formula, is base times height divided by 2. We solve for the base, the bottom of the triangle, that's 48, and we have the height, it's 14. Perfect. Plug it into the formula, and we're good. We get 48 times 14, the height, divided by 2. Plug this on your calculator. 48 times 14 divided by 2, and I get 336 meters squared because it's area. And this is the final answer. So the perimeter of this triangle is 112, and the area of this triangle is 336. And that's how we use Pythagorean theorem to solve for areas and perimeters. Great job. I'll see you guys in the next example. Okay, great. In this example now, it's the same question. Find the area and the perimeter of the following shape. In this case, we have a rectangle. We're given that the diagonal of the rectangle is 61 centimeters and the height, or the width, is 11 centimeters. We're missing the base. To find the perimeter, we need to have all the sides. Well, since this is a rectangle, we know that opposite sides are the same. So if this side's 11, then we know this side here is 11 as well. In order to add up all the sides, we need the top and the bottom. How do we find that? Well, the trick here is that you have to see that in the rectangle we have a triangle. Okay, so you have to focus on this triangle over here. But wait, Pythagorean theorem is supposed to be only on 90-degree triangles. Do we have a 90-degree triangle here? Yes, we do, because if we focus on the bottom half, all the corners of a rectangle are 90 degrees. So this bottom half here, so the triangle BCD, is a right angle triangle. So you can use Pythagorean theorem here. Notice that 61 corresponds to the the hypotenuse, because it's across the 90 degrees. This is your C. And we have our A. And all what's left to do is find the B. So let's go ahead and do that using Pythagorean theorem. So C squared equals A squared plus B squared. C in this case is 61 squared. A is 11 squared plus B squared. So 61 squared, let's do that on the calculator. We get 3,721 equals 11 squared, which is 121, plus B squared. And again, we're isolating for B squared, so we have to put our numbers on the same side. How do we do that? Well, we subtract the 121 because it's adding to the B. So we have to bring it on the other side by subtracting. And what we get is 3,600 equals B squared. Last step, don't forget, square root both sides. So the square root of B squared is B, and the square root of 3,600 is 60. So the base over here is 60 centimeters. Now that we have the base, we could find the perimeter, because if the bottom is 60, this is a rectangle, the top has to be 60 as well. So this is 60 centimeters. How do we find the perimeter? Add up all the sides. So the perimeter of the rectangle is 60 plus 11 plus 60 plus 11. That gives us 60 plus 60 is 120, plus 11 is 22. So this gives us a perimeter of 142 centimeters. Okay, so the perimeter of the rectangle is 142 centimeters. Next, we have to find the area as well. How do you find the area of a rectangle? You have to remember your formula that the area of a rectangle is length times width. Or you could use base times height, whatever your teacher uses, that's fine. Let's use base times height, why not? So the base in this case is 60 times the height, which in this case is 11. So 60 times 11, 11 times 6 is 66, add the 0. And don't forget your units, centimeters squared, because it's area. And that's how we find the area of a rectangle and the perimeter of a rectangle using Pythagorean theorem. So you can see that Pythagorean theorem is useful because it doesn't only show up in right angle triangles, it could show up in other shapes. Great stuff. Let's continue with more examples. Hey everyone, let's continue with our next example using Pythagorean theorem. Once more, we're asked to find the area and the perimeter of this shape. The shape that's given here is a right trapezoid. It's a right trapezoid because this side here is 90 degrees and that's 90 degrees. Okay, and it's asking us to find the perimeter and the area of this trapezoid. How do we do that? And why does this relate to Pythagorean theorem? So notice that to find the perimeter, you have to add up all the sides. We have the top, we have the bottom, it's 49, and we have the left side, it's 24 millimeters. We're only missing this side here, the length BC. Okay, and the trick to these questions is that you have to kind of cut the trapezoid into a rectangle and a triangle. By making this cut over here, we could focus on this triangle and use Pythagorean theorem to find the missing side. That's the trick. So cutting it this way. Now that you know the trick, I urge you to pause the video, try to solve it yourself. Okay. So hopefully you guys had luck solving the problem. Let's continue together. So what you have to notice is that AB, this side that we added here, and the base over here, this is a rectangle, which means that if the left side is 24, this side, the line that we drew has to be 24 millimeters as well. It's a rectangle. Okay. So we have one side of this triangle, this little mini triangle we created. It's 90 degrees, perfect. But in order to find BC, we need the bottom. How do we find the bottom? The trick is to notice that the top, the length of the, let's say we consider the rectangle, the top of the rectangle has the same dimension as the bottom. So this is 42 millimeters as well. So if this is 42 milliliters, and the whole thing is 49 millimeters, how much is missing? And that answer gives us the answer for the base of the triangle, which is what we want. So in order to do this, you have to do 49 and subtract out the 42. And what you're left with is 7. So this little piece here is 7 millimeters. Okay, so you do 40, let's do it on the side, 49 minus 42 equals 7. And that gives us this piece. So now our triangle, our right angle triangle, we're able to use Pythagorean theorem because we have the base, we have the side, and we're looking for the side that's opposite to the 90 degree, which is your C. We're looking for the hypotenuse. So let's go ahead and solve. C squared equals A squared plus B squared. Our C is what we're looking for. Our A, we could call this side A, this side B. Our A is 24 squared plus B squared, which is 7 squared. So we get C squared equals 24 squared. 24 squared, we get 576. Plus 7 squared, which is 49. And now we just add the two terms. 576 plus 49 is 625. And the last step of Pythagorean theorem is square rooting both sides. So we get C equals 25. Does that make sense? Yes, it does. We found the hypotenuse, longest side. It's bigger than 24. It's bigger than 7. We're good to go. So we're confident with our answer. So this side here, let me rewrite it as 25 millimeters. And now we have all the sides that we need in order to find the perimeter of the trapezoid. So perimeter of trapezoid, I'm going to abbreviate it as trap. So perimeter of trapezoid is equal to, let's add the top, 42, the left side plus 24. Be careful here, use the whole bottom. Don't add 42 plus 49 plus 7, that's a common mistake. You add the whole bottom. The whole base here is just 49. Don't add the values twice. So the whole thing's 49, and then we have the right side over here, which is 25, so plus 25. And when we do this, 42 plus 24 plus 49 plus 25, we get 140 millimeters. So this is the perimeter. So we got the perimeter. The next part is the question's asking us for the area. So to find the area of a trapezoid, you guys have to remember the formula. It's big B plus little b times height divided by 2. Okay, so let's put that in. The big base is the bottom over here. It's the longest side. That's 49. Plus the little base, which is the top here, that's 42. Times the height. The height, don't use the slant height. You have to use the vertical height. So either 24 here or this 24. And then divide your answer by 2. So we do brackets first. So 49 plus 42. This is 91. So you get 91 times 24 divided by 2. So make sure you do the brackets first, then you multiply. So 91 times 24, and that answer divided by 2, we get that the area is 1,092 millimeters squared, and that's the final answer. Hopefully you guys got the same answer. If not, try to follow the work that I did over here, and keep up the great work. I'll see you guys in the next video. Hey everyone, welcome back. Let's continue with another example. So still the same question, find the area and the perimeter of the following shape. In this case here, we have a right angle triangle inscribed inside a circle. Okay, and our job is to find the area and the circumference of the circle. We don't say perimeter, we say circumference. Okay, so I'll write down the formulas in just a second. But the key to this problem is to catch that in our 90-degree triangle, we have to find the base. And the base corresponds to the diameter of the circle. So in secondary 2, you should have learned about diameters and radius of a circle. The diameter is from one side of the circle, and it travels to the other side of the circle. It's a straight line, and it passes through the origin, the center of the circle. So this straight line here passes through the center. That's what we have to find. How do we do that? We use Pythagorean theorem. Since we have a 90-degree triangle, fixate on the 90-degree triangle and use Pythagorean theorem. Which side are we looking for? Well, if the 90 degrees is on the top here, then the side we're looking for here, this is your C. It's the hypotenuse, the longest side. And we have the two legs. So we have, let's call this side A and this side B. So we use Pythagorean theorem, C squared equals A squared plus B squared. C is the whole side that we're looking for, that's the diameter. a squared is 6 squared, plus b in this case we called it 8 squared. So c squared equals 36 plus 64. We add the numbers, we get 100. And then the last step, we square root. So c equals 10 meters. Does that make sense? Yep. The hypotenuse is the longest side, 10 is bigger than 6 and 8. Let's keep going. So we know the whole distance, the whole bottom of the triangle. Let's take this out. Let's put this as 10. Can we figure out what the radius is? Well, you guys have to remember for circles, the diameter, let's call it d, is equal to 2 times the radius. Let's call it r. Okay, so if you multiply the radius twice, you get the diameter. Well, we have the diameter. 10 is the whole base, that's the diameter. So to find the radius, we just divide it by 2. So the radius in this case is 5. Why do we need the radius? Oh, well, the radius of the area of a circle, should we do area first? Okay, let's do area. The area of a circle is pi r squared. This is a circle, so the area of a circle is the formula pi times r squared. Well, now that we found the radius is 5, you plug it into the formula. So we replace the r with 5. So what we get is the area of the circle is equal to pi times 5 squared. We do exponents first, so we get pi times 5 squared is 25. And we can leave our answer like this as 25 pi, or we could put as a decimal and multiply this. You could also use the number 3.14 if your teacher accepts that. Those are all okay answers. So we could also approximate this to 3.14 times 25, which is about 78.54. Okay, and the units are meters squared because it's area. If you're off by like 0.1, that's okay as well. And next we have to find the circumference of the circle all around. So the area of the circle, remember, is everything on the inside. The circumference of the circle is the perimeter. How long is, let's say, the ring of the circle? If we're going to put a fence around the circle, how long would that fence be? That's the idea. And the formula is 2 pi r, very similar to pi r squared, but the circumference is 2 pi r. Well, again, pi is just a number. You could write it as 3.14, and r we found the radius, it's 5, using Pythagorean Theorem. So this is just 10 pi. You could leave your answer as 10 pi, or you could do pi on your calculator times 10, and you'll get about, I'm going to put like squiggly lines for approximation, 31.42 meters. Circumference, the units are just meters. Area, it's meters squared. Okay. Hopefully you guys got the same answers, and keep working hard, and I'll see you guys in the next example. Hey everyone, welcome back. Let's keep going with another example. So in this example, it's asking us to find the height of this triangle. Okay, so we know the left side here is 13, we know the base is 10, and we have these little tick marks. These little tick marks mean that this side here is the same as this side. In other words, this is an isosceles triangle where two sides are the same. So if this left side here is 13, the right side here is also 13. So let's write that down. Again, we call this an isosceles triangle. Two sides are the same. And also, let me just mention, two angles are all the same. But we don't really need that right now. But it is true for isosceles triangles. So more importantly, what are we looking for? We're looking for the height. So the height of the triangle, let's do a little sketch, is this line. Can we use Pythagorean Theorem on an isosceles triangle? No, because it's not 90 degree. We need 90 degree triangle. If you use 10 and 13 and plug it into the formula for Pythagorean Theorem, that's wrong. Okay, so be very careful. The trick to these types of problems is you have to create a 90 degree triangle. How? By splitting it down the middle and considering only one side, either the right side or the left side of the triangle. Notice now the right side, 8 down to the bottom here to the right side, this is now a 90 degree triangle. Because whenever you draw a height, that's always 90 degrees. We assume it's perpendicular. Okay. So let's focus on the right side. On the right side, we have 13. This is your C, it's the longest side because it's the side opposite to the angle, the 90 degree. And what's the base? How do we find the base? Well, if the whole bottom is 10 and we cut it down the middle, this side is half of 10. So So you do 10 divided by 2, and that gives us 5. So the bottom of the triangle that we're using is 5. So we have to consider this new triangle, half of it, where the bottom is 5 meters, and the right side is 13 meters. And we're looking for the height, which we'll call, instead of question mark, let's put b. So we're looking for b here. Let's go ahead and do that. So c squared equals a squared plus b squared. And let's plug in what we know. We know the hypotenuse is 13. Let's call the bottom a since I called the left side b. So a is 5 squared plus b squared. And now we solve. 13 squared is 169. 5 squared is 25. And b squared. So remember, we're trying to solve for b. We have to isolate b. How do we do that? Bring the 25 over. Put our numbers with our numbers. It's positive. We bring it over to the other side. We subtract. It becomes minus. So 169 minus 25. And we get 144 equals b squared. Last step of Pythagorean Theorem, square root both sides. I'm going a bit faster now because we've done a lot of practice in the previous examples. So hopefully you guys are comfortable with this by now. So when we solve for b, we get 12. And b corresponds to the height of the triangle. Does 12 make sense? Yes, it does, because the hypotenuse is 13, and this side has to be smaller than the hypotenuse, because the hypotenuse is the longest side. 12 is smaller than 13, so we're happy with this answer. So the height of the triangle, this dotted line that we drew, is 12 meters. Okay, hope this helps, and we'll see a similar example in the next video. Hey everyone, let's keep going. So in this example, let's maybe call this example 3 now. Very similar to the last example that we saw, where it asks us to again find the height of this triangle. Notice now that we have tick marks on all the sides. All 3 sides have tick marks, which means that all the sides are the same. They're all 14 centimeters. We call this type of triangle an equilateral triangle. All the sides are the same, so an equilateral triangle. And we use the same trick that we saw with the isosceles in the previous example to find the height. So we split it down the middle, and now you guys know what to do. So I'll let you guys pause the video, try to solve it on your own, and see if you get the same answer as me. So now that you unpause the video, let's keep going. This is 90 degrees. The bottom is 14, the entire bottom, but we're focusing on just 1/2 of the triangle because we wanted to use Pythagorean Theorem on a 90-degree triangle, not on an equilateral triangle, so we have to be careful here. So if the whole base is 14, that means that the right side is just 7 centimeters. And now we're focusing on this triangle, something that looks like this. The bottom 7 centimeters, the right side's 14 centimeters. This is 90 degrees. And we know this, the hypotenuse, the longest side. We have, let's say, D, and we're looking for A. So let's go ahead and solve for A. Notice I switched A and B from the last example, but it doesn't matter because these are the legs. It doesn't matter what you call them. The only one that matters is the longest side is C. So let's apply Pythagorean Theorem. C squared equals A squared plus B squared. We replace our C with 14. We replace our B with 7, so we're looking for A in this case. So we get 7 squared. 14 squared is 196, is equal to A squared plus 7 squared is 49. And we're trying to isolate the A now. How do we do that? Well, we're adding 49. What do we have to do? Bring the 49 with the 196 because we want to put our numbers with our numbers on the opposite side and our variables with our variables. So we subtract 49 on both sides. Right. So by doing that, 196 minus 49 is 147 equals A squared. And the last step is to square root your answer. Notice in this example we get a decimal, but that's okay. That's fine. It won't always be a whole number. So we get 12.12 centimeters equals A. So A was this length of the triangle, which ends up being the height. So the height is 12.12 centimeters. Does 12.12 make sense? Yes, because the hypotenuse was 14, so the height had to be slightly smaller. 12 is smaller than 14, so we're good. Awesome. So the height of the triangle, the equilateral triangle, is 12.12 centimeters. This is the final answer. Notice that now if you wanted to find the area of the triangle, you're able to, because we have the base, it's 14, and we just solved for the height, 12.12. So you would be able to find the area if that was asked. Awesome. Keep up the great work, and I'll see you guys in the next video. Hey everyone, welcome back. Let's take a look at this example. This is a nice example, often shows up on tests, so make sure you're comfortable with this. Give it a shot, pause the video, try it on your own, see if you're able to solve it before I solve it. But let's go ahead and do it. The question is asking us to solve for x. We have to find x. What we have, we saw this in the last video, 2 tick marks. These 2 tick marks means it's an isosceles triangle, meaning that both these sides are the same. We don't know what they are, but they're the same. And moreover, it's a 90-degree triangle. So we have, in this example, a right isosceles triangle. So how do we find the missing values for a right isosceles triangle? Usually we have two sides, and we solve for the third. In this case here, we only have one side that we know, and we have to find 2 missing sides. How do we do that? Well, the fact that these sides are equal helps us out a lot. So let's go ahead and use Pythagorean Theorem. Notice that the 9.9 in this example is your c, it's the longest side because it's across the 90-degree angle. And let's apply Pythagorean Theorem. C squared equals a squared plus b squared. This example here requires a bit of algebra, but secondary 3 we should be comfortable with this. We replace c with 9.9, so 9.9 squared equals a in this case is x, and b in this case is x. So we replace your a with x, so we get x squared, and we replace our b with x, which is also x squared. Okay, so the next step is 9.9 squared. Let's do that on the calculator. You should get 98.01. And x squared plus x squared, how do we do that? Well, x squared, they're common terms. So we could group them, we could add them together. We can combine like terms. So in essence, x squared plus x squared is 2x squared. Okay, that's okay. How do we solve for x now? So the first thing we have to do is get rid of the 2. The 2 is multiplying the x squared. So what do? Inverse operation. What's the opposite or the inverse operation of multiplication? In our case, it's division. So we divide by 2 on both sides. So 98.01 divided by 2, we get about 49.005, and that's equal to x squared. Okay, we've seen this before, where we had the last step is c squared or a squared or b squared. In this case, it's x squared. How do we get rid of the square? Well, the last step of Pythagorean Theorem, square root. So we square root both sides. Let me write my answer over here. So when you square root 49.005, you get, let me continue on the right side here, 7.00035. So I'm going to put about 7. I'm going to round my answer. And that's what the x value is. So your x value here is about 7 centimeters. And we found the answer. Awesome. I hope you enjoyed the video. Let's keep practicing, and I'll see you in the next example. Okay, great. Let's continue. So in this example here, it's asking us once again to solve for x. So they give us this triangle, ABC. We're looking for this side, x. We have this side is 42 decimeters, and we have this side is the square root of 2020 decimeters. So don't let the square root of 2020 disturb you or bother you. That's just a number. Okay. So, and more importantly, it's the longest number. So if you want, you can rewrite it as a decimal, plug it into the calculator. But the important thing here is to catch that that's your hypotenuse, because this is your 90 degree. That's the longest side. That's your c. It's the hypotenuse. Let's call 42 b, and let's say we're solving for a. So when you apply Pythagorean Theorem, c squared equals a squared plus b squared. C squared, c in this case is square root 2020, and we're squaring it, equals a squared, which is x squared, because a is x, and b is plus 42 squared. And if you do this on the calculator, the square root of 2020, all that squared, should give you back 2020. Because the square root and the square cancel each other out. So we just get 2020, that's equal to x squared plus 42 squared. So 42 squared is 1,764. So So again, we're solving for x squared. We subtract the 1764 because we want our numbers on the same side. And we get 2020 minus 1764, we get 256. The last step of Pythagorean Theorem, square root, x equals 16. The units in this case here were decimeters, dm, so it's 16 decimeters. And this is the final answer. This is a very typical part B question on an exam. So hopefully this helps, and I'll see you in the next example. Hey everyone, let's keep going. This is a great example. This one shows up very often on class tests. So we're asked in example 6 to find the height of the chalk before it broke. So this, you have to envision a piece of chalk. The chalk cracked in half and tipped over. What you have to see here is that this forms a small little triangle here. A 90-degree triangle. Your goal is to find how tall the chalk was before it broke. We're looking for this. Okay. So this is the piece of the chalk. This is the piece that should have been there that tipped over and fell. That's where it is now. But if we take this piece and put it back on top, how tall is the chalk going to be? Well, we know the bottom of the chalk is 21 millimeters, and we know it fell 20 millimeters away. The top of it fell 20 millimeters away from the base. How are we going to find the original height? Well, to find the original height, we have to find the height of the piece that broke off, and then put it back. So our goal is to find the height of the piece that broke, which is essentially your C, because that's the piece that's located across the 90-degree angle of the triangle. So you're really looking for the hypotenuse. Okay. So the base is 20, the height is 21, because if this is 21, this side's 21. I mean, that's how tall it is. And we have to find our C. So we apply Pythagorean Theorem, c squared equals a squared plus b squared. And they do this often with trees that fall, or a piece of chalk that breaks, a pole that breaks. Very typical questions like this. The only thing that changes is really the picture, but it's the same concept. So we're looking for C. Our A, let's call this the A, this the B. A is 20 squared plus B is 21 squared. So we get C squared equals 400 plus 441, 21 squared, 441. So we add them, 400 plus 441 is 841, and the last step we square root. So C equals 29 millimeters. Okay. So if you stop there, it's too soon. You're not going to get full marks on the test because you got, this is 29 millimeters. But the question's asking for the height before the chalk broke. So if we put this piece back on top, how tall is the whole thing going to be? Well, if this is 21, and this piece over here, if we pick it back up and put it on top, gives us 29. We have to add 21 plus 29. So 21 millimeters plus 29 millimeters gives us 50 millimeters. So the height of the chalk is 50 millimeters. And that's the answer. Hope this helps, and I'll see you guys in the next example. Keep up the great work. Hey everyone, in this example we're going to take a look at a slightly more difficult problem. This one over here asks us to determine the value of x. So we're looking for the distance between C and D. We're given the distance from A to B is 12, the distance from A to C is 13, and the distance from A to D is 20 meters. Okay, so my question before you start solving is, how many triangles do you see here? So if your answer was 2, that's wrong. There's actually more than 2 triangles here. So we have triangle ABC, the left side one, here. we have triangle ACD, that's 2. And then we have the whole image, which is a triangle as well, triangle ABD. That's a big triangle. So we actually have 3 triangles here. And my second question to you is, how many 90-degree triangles do you have here? So we actually have 2 90-degree triangles. So a common mistake is that students use Pythagorean theorem here on triangle ABC, and then they use it again on triangle ACD, on this one here. But this triangle here is not 90 degrees, so you cannot use Pythagorean theorem on triangle ACD. Okay, so don't fall for that trick. So the trick here is to first begin by finding the distance from BC. This is step 1. Okay, so if we look at this triangle here, this would be your A. You're looking for, let's call this B. And our C in this case would be 13. So we're focusing on the triangle ABC, the small one. It's a 90-degree triangle, so we can use Pythagorean theorem. So C squared equals A squared plus B squared. Our C is 13. Our A is 12. And we're looking for B. So 13 squared is 169. 12 squared is 144. Plus B squared. What do we do next? We subtract over the 144 because we want to isolate our B. So we get 25 equals B squared. Last step, square root, and we get B equals 5. So the bottom here, the distance from B to C, this is 5 meters. Okay. The next triangle you have to look at is not ACD, but the whole triangle, because you want to work with 90-degree triangles. So ABC is a 90-degree triangle, and ABD is a 90-degree triangle. So now we're working with the big triangle ABD. And our goal is to find the whole base, the distance from B to D. Okay. So triangle ABD now, oops, not C, D. Focusing on this one. Our A, so let's relabel now. So we have to kind of, for an instant, ignore this line here. Kind of forget about it and focus on the left side and be 12. The hypotenuse is 20. This is your C now. And now we're looking for our new B, the big B, let's say, for the bigger triangle. So we use Pythagorean theorem, C squared equals A squared plus B squared. In this case, your C now is 20 squared equals A is still 12. And you're looking for B again. Okay. So 20 squared is 400 equals 12 squared, 144 plus B squared. Subtract over the 144 and we get 256 equals B squared. Last step, square root, and we get 256, right, 16. 16 equals B. Our new B are 16 meters here. So in order to find this distance here, the distance between C and D, we found the little base here, the distance from B to C, and we found the big base, the distance from B to D is 16. In order to find X, what do you have to do to your answers? Subtract them. So the last step would be to find X is 16 minus 5, which equals 11.